Today I'm talking through a Cambridge IGCSE Physics Paper 2 multiple choice from November 2023. How many of the quantities shown are scalars? So the best way to do this is just remember the ones which are vector quantities, because there's fewer vector quantities compared with scalar. So the vector quantities include force, weight, velocity, momentum, acceleration, electric field strength, and gravitational field strength. So if any of these feature here, like momentum, we know that that's a vector quantity, so it can't be scalar. Because we haven't mentioned mass, density, or energy in any of these, then the answer here is, count them up, it's 3C. A train is on a straight track. The graph shows how a quantity y varies with time. Which statements can be true? So if you look down these options, basically we're trying to ask ourselves if it's a speed time graph or a distance time graph and what that would mean for the motion of the vehicle. So I'll just redraw that here. So for argument's sake, we're going to say that this is a distance time graph. And then because the train doesn't change its distance, it means that it must be stationary, and that y represents the distance from the last station. Yes, that would be true if the y-axis referred to distance. And then what happens if it was a speed time graph? Well, this time you'd say that the train was travelling at constant speed, and that obviously the y-axis refers to speed, so this one would be correct. So I think it's 1 and 4, which is option B. The diagram shows a speed time graph for a moving object. Which description of the object's motion is correct? So we can see the speed increasing over time, so that means that acceleration is occurring, but because that graph line is less steep, it means that it's decreasing acceleration. The mass of air hitting the blades of a wind turbine each second is the following mass. The speed of air is this. The density of air is this. Which row gives the volume of air hitting the blades each second and the kinetic energy of the air hitting the blades each second? So we have mass, speed, density, we're after volume, as well as kinetic energy. So let's start by writing the equation for kinetic energy, which is half mv squared. We have enough information to find the kinetic energy. Just sub in your mass and your speed value to get 120,000 joules. What about the volume? This time you're using this formula triangle, which states that volume is mass divided by density. So that's 1.5 times 10 to the 4 divided by our density, which is 1.2. And that comes out at 12,500 meters cubed. So just look along the row and you can see, therefore, that the answer here is B. An object moves in a circle at constant speed. Which statement about the force needed on the object is correct? So it's moving in a circle at constant speed, so we know that centripetal force will be acting towards the centre of the circle, and it's that centripetal force which keeps the object moving in the circle. So the answer here is C. A uniform rod rests on a pivot at its centre. The rod is not attached to the pivot. Forces are then applied to the rod in 4 different ways as shown. The weight of the rod can be ignored. Which diagram shows the rod in equilibrium? So when the rod's in equilibrium, we know the clockwise moment equals the anti-clockwise moment. So this is a clockwise moment, this is an anti-clockwise moment. You've got the same force on each end of the beam, so I think it's likely to be A. Just check the others. Right, that force is acting upwards here, that one's acting there. That's actually going to cause the rod to ping off the pivot, because it says here it's not attached. So obviously it's not in equilibrium, so it's not B. These are both acting in a clockwise direction, so it will be turning that way, so it's not C. And then hopefully you can see straight away, look, it's never going to be in equilibrium because these forces are different, so it's not D. The answer is, as I thought, A. A car of mass 1200 kg is travelling along a straight horizontal road. Which impulse is needed to accelerate the car from 5 meters per second to 10 meters per second? So impulse is given by the equation force times time for which the force acts. So we don't have enough information yet. First of all, we need to get our mass into weight. Remember, weight and force have the same unit, which is newtons. So that's quite straightforward. We just do 1200 times gravitational field strength to get 12,000 newtons as our force. Next up, in order to find time, we need to use this equation, which is force equals change in momentum over time. How do we find the change in momentum? Well, we need to find the momentum before using the equation mass times velocity. We know the mass was 1200 kg. The initial velocity was 5, so the momentum before is 6,000. What about the momentum afterwards? Well, again, we need to use our mass of 1200, this time multiplied by the final velocity, which was 10, to get an answer of 12,000. So what's our change in momentum? It's 6,000, so we have enough information now to solve for x. So our time value is 0.5. So lastly, there's our force, 12,000, times it by 0.5, and therefore our impulse is 6,000. A mass bounces up and down on a steel spring. The diagram shows the mass in the spring at different points during the motion, at which point is the least energy in the gravitational potential store of the mass, and at which point is the most energy in the elastic store of the spring. So the least GPE, the least gravitational potential energy, is when the spring is at its lowest point. It's got the least height. And then the most energy in the elastic store of the spring is coincidentally when the spring is at its lowest point, when it's most stretched. So the answer here is D. A boy uses a rope to pull an object of mass m up a slope. The rope is parallel to the slope. The tension in the rope is constant and of value F. The object moves a distance d along the slope and rises through a height h. How much work is done by the boy? So work done equals force times distance. That's an equation you'll need to learn, so the answer here is A. A microwave oven is rated at 900 watts, so that's its power. Which statement correctly describes the meaning of this value? So power is given by energy divided by time. What are the units of energy? Joules. What's the unit of time? Seconds. So it's the amount of energy transferred every second. So the answer is A. An object is immersed in a liquid of density ρ. The pressure at this depth due to the liquid is P. The gravitational field strength is G. What is the equation for the depth h of the object beneath the surface? So pressure difference is density times height times gravity. So rearrange that to make height the subject of the formula. So we can see that the answer here is C. A sealed bottle of constant volume contains air. The air in the bottle is heated by the sun. What is the effect on the average speed of the air particles in the bottle and the average distance between them? So obviously, as the particles are heated, they'll have greater kinetic energy, which will increase their speed. The fact that the bottle is sealed means that the average distance between the air particles stays the same. In an experiment to investigate the relationship between the volume of a sample of air and its pressure, the volume of the sample is decreased and the pressure is measured continuously. Curve X on the graph shows the results that would be expected for a fixed mass of air at constant temperature. Curve Y shows the results that were obtained in this particular experiment. Which row shows two possible reasons why curve Y is different from curve X? Okay, the first thing I want to consider is the effect of temperature, because look at these options over here, they're all to do with temperature. Clearly, when you lower the temperature, the particles have less kinetic energy, they collide with the walls of the container with less force, therefore reducing the pressure, because pressure is force over area. So one of the reasons for that lower pressure could be because the temperature has decreased. And then what's another reason why the pressure may have reduced? Simply because some of the air has leaked out, which is why D is the correct answer. A student splashes water onto her face. Here are 3 statements about the effects. So you can think about splashing water onto your face in the same way. How does sweat help to cool the body? Well, remember, it takes energy to evaporate the sweat from your body, and it's that loss of thermal energy which causes the cooling effect. So it's going to be similar here. Yes, the water uses energy to evaporate. Where does that energy come from? The student. Yes, cooling takes place. So the answer is P, Q, and R, which is D. 4 containers each contain water. More water at the same temperature is added to each container. From which container does water now evaporate more slowly than it did before? Don't overthink this. Look at the container shape, which has a smaller area for evaporation. It's C, so the answer is C. A cupboard is placed in front of a heater. Air can move through a gap under the cupboard. Which row describes the temperature and the direction of movement of the air in the gap? So this is all to do with convection currents. If the heat source is here, we know that the air is going to expand, and that's due to the particles having more kinetic energy. So because the air now has less density, it's going to rise and become cooler and then sink, setting up that convection current in this direction, which is going to draw cool air in that can then be heated by the heater. So which row describes the temperature and the direction of movement of the air in this gap here? Well, it's going to be comparatively cooler, and it's going to be pulled towards the heater, so B. Light diffracts when it enters a telescope. This causes the image to blur slightly. The amount of diffraction depends on the diameter of the hole through which the light enters the telescope and the wavelength of the light. Which combination for diameter and wavelength will result in the sharpest image, least blurring? So we want the least amount of dispersion, we want the least amount of diffraction, and therefore you want a large gap and short wavelengths. The answer here is B. The diagram shows a transverse wave. Which row identifies the amplitude and wavelength of the wave? So the amplitude is the distance from the equilibrium point to either the peak or the trough. So P is correct. Wavelength is the distance between 2 troughs or 2 peaks. The answer here is B. The diagram shows the effect of a prism on white light. Some light is reflected on striking the prism, and some is refracted and dispersed to form a spectrum. So there's reflection. Here's dispersion taking place. What happens if monochromatic light is used instead of white light? So remember, white light contains all the colours of the rainbow. Monochromatic light just refers to one colour of light. And as a result, you will not get the dispersion taking place with the monochromatic light, unlike white light, which disperses into all the different colours. The diagram shows a ray of light incident on a plane mirror. The angle between the ray and the mirror is 35 degrees. I don't know why it's used that gamma. The ray is reflected by the mirror. What is the angle of reflection? So we're going to add the normal. Here's your angle of incidence. Because that's a 90-degree angle here, that must mean that the angle of incidence is 55 degrees. And then in terms of the reflected ray, your angle of reflection is here. The law states that the angle of incidence equals the angle of reflection, so the answer is B, 55 degrees. A thin converging lens in a camera produces a real image on a photosensitive surface as shown. At which position is the image of the top of the object formed? So remember, when you draw these ray diagrams, you need a ray that goes through the middle of the lens, and then one that you take horizontally till it meets the lens, and then it comes down here. And so this is going to be your image, and as you can see, it's going to be inverted. And as a result, the answer here, if I clear that up a bit, is C. Light is travelling through air. It strikes the glass block at an angle of incidence of 45 degrees. The glass has a refractive index of 1.4. What is the angle of refraction? So we're using refractive index N is sine I over sine R. The refractive index is 1.4. Sine 45 divided by sine x. So in order to solve that, you're going to do sine x equals sine 45 divided by 1.4, and then press inverse sine on your calculator and put the result of that calculation in, and you'll get an answer of 30 degrees. Which row gives approximate values for the speed of sound in copper, water and air? So the speed of sound is fastest in solids, so copper, then liquids, and then slowest in gases like air. So just work your way through the data and you'll see that the answer is A. Which metal can be attracted by a magnet? So you need something like iron, steel, nickel or cobalt. The only one they've mentioned here is iron. It's a soft magnetic material, which means it loses and gains magnetism easily. The diagram shows an electric circuit. In which direction do free electrons flow around this circuit, and what quantity does the ammeter measure? So because it's asking about electrons, they're going to flow from negative to positive, so in this direction, which is anti-clockwise. The ammeter measures current. You can see here that current is charge divided by time. So we need to pick this option A. It's the charge passing each point in the circuit per unit time. Which substances both contain large concentrations of free electrons? We're looking for metals here because they're electrical conductors. So silver and gold, D. A resistance wire of length L melts and has to be replaced with a wire of the same material and the same resistance. The only wire available has twice the diameter of the broken wire. Which length of this wire should be used? Be a little bit careful here. Remember that when you increase the cross-sectional area, what you do is you decrease the resistance. What they've done is they've doubled the diameter. They haven't doubled the radius, they've doubled the diameter. So in effect, the resistance will now be a quarter of what it was originally. So what you need to do, obviously we need a longer wire in order to increase the resistance, but that wire needs to be 4 times the length of the original wire. A teacher wishes to show the production of electrostatic charges. She holds a rod and rubs it with a cotton cloth. A copper rod, a glass rod, a plastic rod and a steel rod are available. Which 2 rods would both be suitable to use? Because she wants to show electrostatic charges, we need to have electrical insulators. By definition, this can't be a metal, so we get rid of these options, leaving us with the glass and the plastic rod. 2 resistors with resistances R1 and R2 are used as a potential divider. What is the relationship between R1, R2 and potential differences V1 and V2? You just need to remember that the equation for 2 resistors being used as a potential divider is R1 divided by R2 equals potential difference 1 divided by potential difference 2. So the answer is D. The diagram shows the light-dependent resistor LDR connected to a potential divider circuit. The brightness of the light falling on the LDR is increased. Because you've got increased light intensity, what that does is it decreases the resistance on the LDR. Which row shows what happens to the resistance of the LDR and what happens to the reading on the voltmeter? Now, because you've decreased your resistance, clearly the reading on the voltmeter will also decrease. The answer is A. A simple AC generator has a coil rotating in a magnetic field. What happens to the peak electromotive force, EMF, and to the frequency of the alternating current output when the coil is rotated faster? Because the coils are going to be cutting the magnetic field lines faster, it means you'll have a greater peak EMF. And remember, frequency refers to the number per second, so therefore that will also be greater. A current passes along a wire placed between the poles of a permanent magnet. The wire experiences a force due to the magnetic field. What will change the direction of this force? So increasing the current just increases the force strength, doesn't change the direction. Reversing the current, yes, because it will now be flowing in that direction, magnetic field lines always run from north to south, and then using Fleming's left-hand rule, which states that the thumb shows the direction of the force, the first finger shows the direction of the magnetic field, which remember is always north to south. The second finger shows the direction of the current. Now, by changing the direction of the current, clearly you'll change the direction of the force. What is a transformer used for? So a step-up transformer will increase the voltage, therefore reducing the current and reduce how much energy is dissipated when electricity passes along the national grid. So yeah, we're going to be changing the size of that alternating voltage. The scattering of alpha particles by thin gold foil provides evidence for the nuclear model of the atom. 2 alpha particles of the same energy are incident on a nucleus of gold, so they're fired at the gold nucleus, which diagram shows the correct paths followed by alpha particles as they pass close to the nucleus. Remember, alpha particles consist of 2 protons and 2 neutrons. As a result, they have a positive charge. The nucleus, remember, has a positive charge because it just contains protons and neutrons. These 2 positive charges will repel each other, and obviously the alpha particle, which is closest to the nucleus, will be repelled more strongly, which is why the answer is A as opposed to C. The half-life of carbon-14 is 5,700 years. An object containing carbon-14 has a count rate of 100 counts per minute when it's first formed. The graph shows how the count rate decreases over time, which point on the graph corresponds to a time 11,400 years after the formation of the object. So first of all, work out how many half-lives have taken place. So after 5,700 years, that's 1 half-life. And then after 11,400 years, that's 2 half-lives. So if you start at 100 counts per minute, after 1 half-life, you'll be left with 50 counts. The second half-life, you'll be left with 25. So if we add labels here, just make sure it corresponds. We need 25 counts per minute left, which is why the answer is D. Why are beta particles deflected more strongly than alpha particles when they enter an electric field? So remember, beta particles are fast-moving electrons which have a very small mass of around 1 divided by 2,000. So they're much lighter than alpha particles. They have much less mass. So the answer here is A. It's not because they're negatively charged. They've only got a 1- charge versus the +2 charge of alpha. Just check that you're happy. Look, beta particles, well, they're electrons, they're going to be moving faster than the alpha particles. And lastly, beta particles have more ionizing power. No, they have less ionizing power than alpha particles. So go through the other options and make sure you're happy with why they're wrong. Which statement describes how nuclear energy is released by fission in a nuclear power station? So remember, nuclear fission refers to neutrons being fired at something like uranium-235, causing the splitting of the nucleus, releasing 2 to 3 neutrons. So the answer here is B, as to heavy nuclei being split into lighter nuclei. The diagram shows a star S and the initial arrangement of 3 planets, X, Y, and Z. Each planet orbits clockwise in a circle around S. The time for one orbit of Y is 3 times the time for one orbit of X. So Y, look, it's got a larger orbital radius and it's going to be taking much longer, so it's going to be lagging behind X. The time for one orbit of Z is twice the time taken for one orbit of Y, so yeah, Z's going to be even slower and it's got a larger orbital radius. Starting from the initial arrangement, which diagram shows the positions of the planets after X has made one complete orbit. So because Y takes 3 times as long to orbit compared with X, it's only going to be 1/3 of the way through its orbit compared with X that's completed an orbit. So you're picking between A and B. And then, as we know, Z is slower than Y, so honestly, it's only just gotten off the starting blocks. So the answer here is B. The nearest star to the Sun is about 4 light years away from the Earth. A student makes 3 statements about the star. So remember, light year is the distance travelled by light in 1 year. A student makes 3 statements about the star. Light from the star takes about 4 years to reach the Earth. Yeah, I mean, that's obvious. Light from the sun takes about 4 years to travel to the star and back to the Earth. No, that's incorrect. The star is outside our galaxy. How could we possibly know that? The answer here is C. A planet orbits the sun with an orbital period t. The average radius of the orbit is r. What is the average orbital speed? So orbital speed is given by 2 pi r over t. Have to learn that. So the answer here is B.